Hi, I'm Shahul Amir, working as professor in AC department, State Institute of Technology, Controllability. In this session, we are going to discuss about a topic related to linear control engineering, that is called state variable technique. First, I'm going to discuss about what is state variable and what are the advantages of state variables. Then we are going to discuss a problem related to state variable. First thing is, we should know what is state variable. State variable approach is a powerful tool or technique for analyze and design of control system. It's actually a modern approach and also easier for analyze and using digital computers. So generally, we used a transfer function approach to solve systems. Control engineering problems, but it has some drawbacks. The drawbacks are transfer function is defined under zero initial conditions. So if you really want to analyze the system using transfer function, we need to assume that initial conditions is equal to 0. If initial conditions are not is equal to 0, then we cannot. It's very difficult for us to use transfer function approach. Next one is transfer function is applicable to linear time invariant system. If it is non-linear or time variant system, it's very difficult to use transfer function approach. Transfer function analysis is restricted to single input and single output system. If we have a multiple input MIMO, that is multiple output, then it is difficult. Then does not provide information regarding internal state of the system. So these are the four drawbacks of transfer function. In order to overcome these drawbacks, we are going for state variable techniques. So first we are going to discuss a problem related to state variable. First I will read the problem statement and then one by one we will discuss how to solve the problem. Before that, we should know the state model of linear time invariant system. So this is state model. X dot of t is equal to a into x of t plus b into u of t. Y of t is equal to c into x of t plus d into u of t. Here this is output equation and this is state equations, input equations. So we are going to find out A, B, C, D matrix. Using that, we can say something about the system is stable or not, or controllable or observable, etc. like that. And here, x of t is state variables. Okay. Now, using this state equations, we are going to solve a problem. So problem statement is obtain the state model of electrical network shown using minimal number of state variable. So here we have a electrical networks which consist of a source, a resistor, inductor, another inductor L2, a capacitor and a resistor. Okay. Now in order to find the state model of the system, we need to use both Kirchhoff voltage law and the current law. Before that, we have to define state variable, number of state variables. Okay. So and also it should be minimum number of state variable. When we are seeing this, we have two inductors and one capacitor, and this inductors and capacitors are mainly used to define state variable and the resistors mainly used for take output. So here three components, two inductors and one capacitor. So the state variables are three. Okay. So we are going to choose state variable as I1 and I2, that is current through inductor 1 and current through inductor 2 and voltage across the capacitor. These three are I1, I2 and VC. These three are state variables. Okay. And with these state variables, we are going to form state matrix. First, we are going to use Kirchhoff's current law and solve the equation. First, I am going to define, I already told you that I1, I2, Vc are state variables. So I am defining x1 is equal to I1, x2 is equal to I2, and x3 is equal to Vc. These are the three state variables. Okay, these are the assumptions. And you know that I1 is current through L1, I2 is current through L2, and Vc is voltage across the capacitor. By applying Kirchhoff's current law, that is a inductor L2 and a capacitor C, this is L1, L2, this is Vc, and we are assuming assuming current direction. Current is going L1, I1 is direction is like this, and I2 direction, and I3. So all the currents are going away from the node A. So sum of the current through these elements, that is inductor and the capacitor, given as I1 plus I2 plus I3 is equal to 0. So I1, I2 and I3 is C, voltage across the capacitor, okay, Vc, and current through the capacitor is C into dVc by dt is equal to 0. Now we are going to substitute the state variable, that is we are going to replace I1, I2, Vc by x1, x2, x3. So I1 is equal to x1, I2 is x2, and Vc is x3. In fact, here dVc by dt, so first order differentiation of the third state variable x3 dot, which is equal to 0. In general, state variable, if you really want to form state variable, the equation is x dot is equal to a into x plus b into u. So we need x dot, and then we have to form in terms of x1 and x and u. So I am considering c into x3 one side, and I am pushing the remaining other side. So if I am pushing this x1 plus x2 right hand side, I will get c into x3 is equal to minus x3 minus x2. Now I need only x3 dot. So I am dividing entire equation by c. When I am doing that, I will get x3 dot is equal to minus 1 by c x1 minus 1 by c x2. So this is the first state equation. Using Kirchhoff's current law, we have formed this equation. Now we are going to use Kirchhoff's voltage law. We are going to find two more equations. First, I am going to take first loop, and then we will take second loop. First loop, in first loop we have a source, resistor L1 and a capacitor. Now here we are considering this the center point, and this voltage, that is voltage across the capacitor, is equal to sum of all the voltage across the elements, like that we are assuming. Hence E of t plus I1 R1 plus L in di by dt is equal to Vc. Okay. Now when you are substituting the state variable, I1 is equal to x1. Okay, I1 here a differentiate, first order differentiation of I1, so x1 dot and Vc is equal to x3. So, and also we are going to assume that E of t is equal to u. So when you are substituting all these things, we will get u plus x1 R1 plus L1 into x1 dot is equal to x3. Now, as we know that we need to concentrate on x1 dot, so I am considering L1 x1 one side, and I am pushing all other thing right hand sides. When I am moving u plus x1 R1 right hand side, I will get minus x1 R1 plus x3 minus u. So now I need only x1 dot, so I am dividing entire equation by L1. So I get x1 dot is equal to minus R1 by L1 x1 plus 1 by L1 x3 minus 1 by L1 into u. This is the second equation which is related to first loop. Now I am going to discuss with second loop. Second loop, in second we have a capacitor, inductor and a resistor, and this one, that is voltage across the capacitor, is equal to sum of voltage across these two elements, that is L2 di2 by dt plus I2 R2. Here I2 is nothing but x2 and here di2 by dt is nothing but x2 dash. So x3 Vc is equal to x3 is equal to L2 x2 dot plus x2 R2. We need only this term, that is x2 dot. So I am just keeping as it is and I am moving x2 R2 left hand side. I'll get L2 x2 dot is equal to x3 minus x2 R2. Now I am going to divide the entire equation by L2 when I am dividing x2. Okay, when I am dividing, this will cancel out. So x2 dot is equal to I am writing x2 first. Okay, so R2 by L2 plus plus 1 by L2 x3. So here when I am dividing entire equation by L2, I will get R2 by L2 and 1 by L2. So x2 dot is equal to minus R2 by L2 x2 plus 1 by L2 x3. So this is the third equation. I'm writing these three equations like this is 1 and this is 2 and this is 3. It's the first equation. X1 dot is equal to minus R1 by L1 x1 plus 1 by L1 x3 minus 1 by L1 u. X2 dot is equal to minus R2 L2 x2 plus 1 by L2 x3 and x3 dot is equal to minus 1 by c x1 minus 1 by c x2. So when you are taking first equation, the missing component is x2. Second equation, missing component is x1, and third equation we have x3 is missing. So and also when you are considering the second equation, u is missing and here also u is missing. So when I am writing matrix form, this thing in matrix form, so first I am taking the x1 dot, x2 dot, x3 dots like this matrix. Then I am going to write the coefficient of the state variable x1, x2, x3. Here x1 and x2 is missing, x3 is there and u is there. So I have taken x1 coefficient, x2 coefficient is 0 and x3 coefficient is 1 by L1 and u 1 by L1 and plus 1 by minus 1 by L1 u. So second equation, x2 dot is equal to, here x1 is missing, so first element is 0, second element is this one minus R2 by L2, third element is minus 1 by L2 and here u is missing, so it's 0. And the third equation, x1 value is minus 1 by c and x2 is minus 1 by c and x3 is missing, so it's 0 and u also missing, so it's 0. So this is a state equation, input equation, and output equation is y1 is equal to, we have two resistors. Okay, I'll just show that. So we have two resistors, this one and this one, these two are output. So this is related to I1, is I2. So y1 is equal to I1 R1, this is output equation. Y2 is equal to I2 R2, that is voltage across the resistor. We are considering this output equation. So we have two output variable So the matrix is y1 is equal to I1 R1, y2 is equal to I2 R2. Now we are substituting the state variable. I1 is nothing but x1 and I2 is equal to x2. So we are taking these two equations and forming the matrix y1 y2, and here in y1 x2 is missing, so first component R1 is here and the second component is 0. In y2 x1 is missing, so x1 is 0 and R2. This is the output equation. So this is the state variable. So the final one, this is input and output equation, and this is A matrix, and this one is B matrix, and this is C matrix, and D is equal to 0. So this is the way we can form state matrix for a given circuit. If you have any queries, you can ask me. So you can post in the channel. I will answer that question. Thank you very much.